Hello, ladies and gentlemen, Hello, ladies and gentlemen, Mr. Donahue here again with some chemistry problems. All right, 8.7, exceptions to the octet rule. All right, always exceptions, right? All right, 31, a valid Lewis structure blank cannot be drawn without violating the octet rule. All right, I'm going to cheat and do some movie magic and just write down how many valence electrons everything has. So that's the first step, is figure out how many valence electrons we're going to have to place for these things. All right, and then SO4 minus 2, you can't forget to add those 2 electrons. So we got 32. All right, NF3 is going to look like this, right? And then finish the octet for all those fluorines. And that's only 24. The last 2 go there. Everything has the octet rule, right? IF3, put I in the middle, 3 F's around it, and finish the octet rule for everything involved. Around the outside, that place 24. We have, we have some more to place, don't we? We got 4 more. So lone pair, Iodine's kind of breaking that octet rule, right? Oh no, oh no, ah. All right. PF3, put P in the middle, 3 F's around it. Make those bonds, complete the octets. That takes care of 24 electrons. 2 more go on the phosphorus. Everything's got the octet rule. All right, SBF3, same deal, right? It's going to look just like that one. I'm not even going to bother to redo it. All right, SO4 minus 2, you can remember from previous videos, it's going to kind of look like this, if I remember, among other octet or resonance structures. And then, you know, the octets are fulfilled for the oxygens. And now you go, hey, look, sulfur breaks the octet rule, but you could draw it another way, right? You could draw it where none of it was broken, like that. So you could draw it that way. So our answer to 31's got to be B. There's no way to draw it without violating the octet rule. There's no way around it. 32. Based on the octet rule, boron will most likely form a blank ion. Well, this one's kind of weird, right? Because boron is 2-3. So it's either going to gain 5 electrons for the octet rule, or it's going to lose 3 so that it has a full energy level, which kind of, like, why would you call it an octet rule if this one's actually full with 2? Yeah, it is. All right, so it's full with 2. How does it do that? It loses 3 electrons, so it would become positive 3. 33. Which of the following does not have 8 valence electrons? All right, well, let's figure it out, right? Chlorine had 7. It gained 1. That's why it's got that negative sign, so it has 8. XZ, noble gas, totally has 8. All right, Ti had 4 valence electrons, but this plus 4 means we got rid of them. So now we have 8. RB, wait a minute. RB had 2 valence electrons, and it only lost 1, so now it has 1 valence electron. Am I doing that right? I might be wrong. Totally wrong on that one, aren't I? Yeah, RB totally lied. It didn't have 2. It only had 1. So now it's got 0. But SR, if you take a look, SR is right here. It's got 2 valence electrons. It lost 1. So now it has 1, which is not 8. 1 is not 8. And now you know that. You're welcome. 34. A valid Lewis structure of blank cannot be drawn without violating the octet rule. All right, I'm going to just go to the right answer. All right, how would you solve this? Well, you do, the same thing as you do in the other problem. You figure out how many valence electrons each thing has, and then you try and draw them as best as you can. All right, so these ones, hopefully, you guys can start to look at and you go, well, I got 32 valence electrons, and I have a central atom with 4 things coming off of it. So that's always going to be 1 thing in the middle, the 4 things around it, and those 4 things are going to have a complete octet. So That's my 32 electrons. That's perfect. They're not violating anything. So it's not A, B, or C. All right, let's try SE. We put SE in the middle, 4 F's around it. And complete their octets. All right, well, that takes care of, I can't even count, 8, 16, 24, 32 valence electrons. And we still got 2 more to place. They're going to go as an unshared pair on SE, violating the octet rule, right? So SE now has 10 valence electrons, which is not 8, FYI. All right, so let's try NF3. Put N in the middle, 3 F's around it. Complete the octets for them. Now that takes care of 24. We still have 2 electrons to place, lone pair on the nitrogen. Everything has 8. So the only one where you can't not violate would be choice D. Cool. 35. Why don't we draw double bonds between Be atom and chlorine atoms in BeCl2? So let's first draw that, right? So we look up Be has how many valence electrons? Here's Be, it's got 2, and chlorine's got 7. So we have a total of 16 valence electrons to draw. So put Be in the middle, Cl, Cl, complete the octet, and hey, don't you know it? We've run out of electrons, we're done, right? But why doesn't Be have a complete octet? Well, let's take a look at formal charge. All right, so chlorine has 7 valence electrons. It has 6 at its keeping, and it makes 1 bond. So both of them have a formal charge of 0, which is great. Formal charge of 0, fantastic. All right, but Be, we're looking at, had 2 valence electrons, and now it's making 2 bonds. It has none of its own, and it's making 2 bonds, right? So now its formal charge is 0, which is also favored, right? Yeah. But let's get rid of all this and see what it would look like otherwise. If we did what they were talking about. All right. If we drew double bonds between the Be atoms and chlorine, I'm going to have to get rid of some of this stuff, right? Make sure I don't have too many electrons. Now let's check formal charge. Chlorine would be 7 minus 4 that it keeps to itself and 2 bonds. So its charge would be positive 1. All right, same thing with that chlorine over there. Be had 2, but it has none of its own, but it makes 4 bonds, which gives it a charge of negative 2. So we have things with formal charges of positive and negative when we could just have them another way where they're 0. Yeah, this isn't the right way. So choice A. Give positive formal charges with chlorine atoms and negative formal charges for beryllium atoms. And if anything, chlorine being the more electronegative one, that should, if any formal charge, should be negative. 36. A valid Lewis structure of blank cannot be drawn without violating the octet rule. Same but different problem, right? So first step is always figure out number of valence electrons. We got 28, we got 26, 24, 32, and 16. All right. I'm just going to draw the one that's wrong, or, the correct answer. So it's going to be choice A. All right. So we draw chlorine in the middle, 3 F's coming off the sides, and then complete the octets, right? 1, 2, 3, 4. So now we've used up 24 of our valence electrons. We got 4 left. So they're going to go on the chlorine. There's no way around it. Something's going to be violating the octet rule. Fluorines, they're fine, but the chlorine has 2, 4, 6, 8, 10. No way around it. If you want me to go over the other ones, I will do them in class. All right. So I will see you there in class. Goodbye.